Hey everybody, this is Mr. McKee with Net 125. Today I'm going over packet tracer correction. I'm going to go over lab 7.1.6. Use Wireshark to examine Ethernet frames. Alright. And basically all you need is a PC with a connection to the internet. Alright, there'll be 20 questions to answer in this lab. Alright, we'll examine header fields in the Ethernet 2 frame and use Wireshark to capture and analyze Ethernet frames. Alright, when upper layer protocols communicate with each other, data flows down the Open Systems Interconnect or OSI layers and is encapsulated into a layer 2 frame. Alright, the frame composition is dependent on the media access type. For example, if the upper layer protocols are TCP and IP and the media access is Ethernet, then the layer 2 frame encapsulation will be Ethernet 2. This is typical for a LAN environment. When learning about layer 2 concepts, it is helpful to analyze frame header information. In the first part of this lab, you will review the fields contained in an Ethernet 2 frame. In part 2, you will use Wireshark to capture and analyze Ethernet 2 frame header fields for local and remote traffic. Alright, now it says you need one PC with Windows, with internet access, and with Wireshark installed. I'm going to demo that for you because I didn't assign the Wireshark lab yet. I'm just trying to make sure we get all the bunch of the labs done before that. Alright, okay. So first thing, examine the header fields in an Ethernet 2 frame. In part 1, you will examine the header fields and content in an Ethernet 2 frame. A Wireshark capture will be used to examine the contents of those fields. Alright, and this is how the field description lengths: preamble, destination address, source address. And notice when they say bytes, that's not bits, that's actually bytes. So multiply that by 8. Alright, multiply that by 8, like that's 48 bits. Alright, 48 bits, and so on. Alright. Examine the network configuration of the PC. In this example, the PC host IP address is 192.168.1.147, and the default gateway has an IP address of 192.168.1.1. If you do ipconfig /all, you get this information. Alright. Notice this is your physical address or your MAC address. And notice that that's in hexadecimal, and it's 48 bits. 8 bits divided by 6 sections of 8 bits, or 48 bits. And remember, it's base 16, so 16 bits here, or not 16 bits, 16 possible, how would I say that? It's 48 bits. It's 8 bits right here, 4 bits and 4 bits. And I'll show you that later. Alright. Like this right here would be, this would have as many, I would say, positions or addresses as a 1 octet of a 32-bit IP address. Alright, so like this right here, for these sections, that could represent a full 4 octets of an IP address. But don't get too much, don't get too wrapped around that. Alright, tells what type of adapter it is DHCP enabled, where it's assigned an IP address, auto configuration enabled, link local IP address. Notice this is also in hexadecimal. There's your IP address, subnet mask, when the lease was obtained from the DHCP server, when it expires. Notice it expires in a day, 24 hours. Default gateway is right there in the DHCP server. All right, so that's all about the Ethernet adapter settings. All right, examine Ethernet frames in a Wireshark capture. The screenshots of the Wireshark capture below shows the packets generated by a ping being issued from a PC host to its default gateway. A filter has been applied to Wireshark to view the ARP and ICMP protocols only. ARP stands for Address Resolution Protocol. ARP is a communication protocol that is used for determining the MAC address that is associated with the IP address. The session begins with an ARP query and reply for the MAC address of the gateway router. All right, followed by the 4 ping requests and replies. This screenshot highlights the frame details for an ARP request. Notice the protocol ARP. All right, you look through all that. Source, you have like a timestamp. That's the packet number, frame number, source, MAC address. And notice the OUI is the first 3 sections of the MAC address. So that tells you who the manufacturer is. This just automatically puts in, this was made by Dell. All right. Destination, it's broadcasted out. All right. The length of it, info. All right. And down here, the source, Netgear, destination Dell, which is up there. ARP request, just with some information. You can see that's telling who, up here they're asking who has 192.168.1.1, which is the default gateway, till this IP address. And then it's telling, okay, 192.168.1.1 is at this physical address, that's the MAC address. All right. Takes a little time just to look at it, figure out what's going on. All right, the screenshot highlights the frame details for an ARP reply. All right. So ARP request is number 65. ARP reply is 66. All right. Examine the Ethernet 2 header contents of an ARP request. The following table takes the first frame of the Wireshark capture and displays the data in the Ethernet 2 header fields. All right, preamble. That field contains synchronizing bits processed by the NIC hardware, destination address. All right, in this case, it was broadcasted up to everybody. Layer 2 addresses for the frame. Each address is 48 bits long, or 6 octets, expressed as 12 hexadecimal digits, 0 to 9 and an A to F. The common format is that right there, delimited by colons. All right, source address is the Netgear, all right, and that right there is the OUI for Netgear, apparently. I can look it up, but that's it. The first 6 hex numbers indicate the manufacturer of the network interface card. The last 6 hex numbers are the serial number of the NIC. The destination address may be a broadcast, which contains all ones, or a unicast. Notice that. And when they say all ones, that means it's F would be 1111. 1111. Right? Or 16. Is that right? No, 1111. FF will be, I'll show you guys, but yeah, anyways. Show you guys how that works out. But that's all ones. If you wrote this out in binary, it'd be all ones. All right. Frame type. All right, for Ethernet 2 frames, this field contains the hexadecimal value that is used to indicate the type of upper level protocol in the data field. There are numerous upper layer protocols supported by Ethernet 2. 2 common frame types are here. All right. So that's the value of IP version 4. It's right here, ARP. So notice how that corresponds to this. That value. Data ARP contains the encapsulated upper level protocol. The data field is between 46 and 1500 bytes. FCS, frame check sequence used by the NIC to identify errors during transmission. This value is computed by the sending device, encapsulating frame addresses, type, and data field. It is verified by the receiver. All right, so what is the significance about the contents of the destination address field? Well, notice right here, it's broadcasted out to everybody on the network. And why does the PC send out a broadcast ARP prior to sending the first ping request? It doesn't know the MAC address of the receiving machine yet. All right, so it has to figure that out. Okay. What is the MAC address of the source in the first frame? All right, MAC address of the source. Look back up here. All right, see how it has del 50 as the OUI. If you look down here in parentheses, all right, F0:1F:AF:50:FD:C8. So F0:1F:AF it comes out as del. All right. That just kind of like that helps you out identifying it. All right, so Dell was sending that out. That was the computer's NIC. Broadcasting out to everybody. Hey, who has this? I'm wanting to ping the default gateway. Tell me that should be my address, my IP address. All right. Let's go back down here. All right, what is the vendor ID of the source NIC? In the ARP reply, so the ARP reply is coming back. The source NIC in reply. Source NIC in the reply is right here. All right, source SRC NIC gear is that 3046 9A 99 C5 72. Oh, I'm sorry. The OUI is just comes out to NIC gear. I was giving you the whole MAC address. All right, let me get back down. Okay, what portion of the MAC address is the OUI? Well, you should know that. It's the first 3 octets. Right. What is the NIC serial number of the source? And I'm assuming that it's meaning the reply. So it'd be the source in this case. Would be 99C572. All right. Now I'm going to make this a little bit smaller. Just give me a second. Let's do this over here. All right, here's that. Kind of like that. All right, now it says use a Windows machine. I'm going to use this Linux, my CyberOps workstation. All right, you don't necessarily have to install Wireshark. They expect you to have Wireshark installed for this, but since I'm doing stuff a little bit out of order, you don't really have to as long as you follow along with me. All right, so in part 2, you will use Wireshark to capture local and remote Ethernet frames. You will then examine the information that is contained in the frame header fields. Alright, so determine the IP address of the default gateway on your PC. Actually, you know what? I'll do it on this. I'll do it on my actual computer. I'm gonna save that. It'll be too confusing. Let me do Wireshark. Alright, Wireshark starting. Alright, remind me about that later. When this first comes up, see I have a whole bunch of different adapters. Pretty much as long as you don't click on like a loopback, but yeah, I even have this computer set up to get on my VLAN for my the outside network, so there's like a lot of stuff going on. And then these local area connection 10 and 8, I believe that's for the virtual machines, virtual machines. Alright, so there's a whole bunch of stuff going on. This much stuff shouldn't be going on your computer. But now if you go to, let's see, so let's open up the command prompt, ipconfig. Alright, notice I have to scroll up, but that's my default gateway, 192.168.254.252. Alright, that's my IP address on this physical machine. Everything else you probably won't have, but that's all these a lot of that are virtual adapters for my virtualization stuff. Alright, so if I open that up, alright, so watch all the packets start coming in there. Alright, you can either use the filter in Wireshark to block, you can use filter in Wireshark to block visibility of unwanted traffic. The filter does not block the capture of unwanted data, it only filters what you want to display on the screen. For now, only ICMP traffic is to be displayed. In the Wireshark filter box up here, type ICMP, hit enter. The box should turn green. Alright, which it did. If the box is green, click apply. Alright, it should work. Alright. Alright, from the command prompt window, (192.168.254.252). Alright, see how I'm getting ICMP data coming up there? Alright. Alright, click the stop, that red square right there. Alright, stops the packet capture. Examine the first echo ping request in Wireshark. Right. Notice the first one, 527, it goes down to 546. Alright, the Wireshark main window is divided in 3 sections. The packet list pane, which is top, the packet details, which is right here, and the packet bytes, which are at the bottom. Alright. If you selected the correct interface for packet capturing previously, Wireshark should display the ICMP information in the packet list pane of Wireshark. In the packet list pane, click the first frame listed right here. You should see echo ping request under the info setting, right there. All right, length of the frame 74. The second line in the packet detail shows the Ethernet 2. Wait, the first line in the packet detail is right there. That's what it's talking about. You can click that to expand it. 74 bytes. Capture on Ethernet 0. The second line in the packet details has the Ethernet 2 frame. The source and destination MAC address are also displayed. Alright, source. This is a Dell PC I'm on. Alright, destination Palo Alto. So that makes sense. What is the MAC address of the PC NIC? Alright. I wonder if I can zoom in. Zoom in is Control++. Control++. Alright. So what is the MAC address of the PC NIC? That's right there. You can do it either way, but that's more correct. Alright. What is the default gateway's IP MAC address? It's right there. Notice how it's down here. It's actually represented down there. Alright. You can click the greater than sign at the beginning of the second line to obtain more information, which I already did. Right there. Alright. What type of frame is displayed? There's the type right there. Alright, and if you go up here, frame type, 800 IP version 4 address, or protocol. Alright, the last two lines displayed in the middle section provide information about the data field of the frame. Notice that the data contains the source and destination IP address information. Alright, right there, IP version 4, source, which that's right, destination, that's right. Alright, and you can use all my information I'm showing you right now. You can click any line in the middle section to highlight that part of the frame, hex and ASCII in the parts bytes pane. Alright, down here. And notice this is in hexadecimal. Alright, and this is in ASCII. Alright, see that? Alright, let's see. We did that. Click the Internet Protocol message protocol line in the middle section. Alright. Examine what is highlighted in the packet bytes. Alright, I hope I didn't lose too much, but now I'm at, let's see, step 7, which is capture packets from remote host. And if you guys missed my recording, software had a little issue. So what is the last two highlighted octet spell? It spells HI. What device in Mac is displayed as the destination address? And that would be the Dell. Alright. So I'm going to go ahead and go to step 7. Alright. I'm going to click stop capture, continue without saving. Alright, I'm going to go down here to command prompt, and I'm going to type in ping cisco.com. Hit stop. All right. Examine the data in the packet list pane of Wireshark. The first echo ping request frame. What are the source and destination MAC addresses? So source is my PC. Destination is the default gateway. All right. What are the source and destination IP address contained in the data field of the frame? All right, let's go up here. All right, so let me get back down here. All right, so what are the source and destination IP addresses contained in the data field of the frame? All right, so if I go down here, Ethernet protocol version 4, notice source is my computer, destination is the actual IP address of cisco.com. All right, compare these addresses to the addresses you received in step 6. The only address that changed is the destination IP address. Why has the destination IP address changed while the destination MAC address remained the same? You guys should be able to answer that, but here's a hint. The MAC address is the same because the MAC address is going out to the default gateway. But then after that, when it's routed out into the internet, it takes off that layer 2 encapsulation and has the IP address in there. And then it gets it to this destination. When it gets to that destination network, that router will put back on the a layer 2 frame inside the network and actually route it to its MAC address. All right, but that's why. Reflection question. Wireshark does not display the preamble field of a frame header. What does the preamble contain? All right, to answer what does the preamble contain, it's right here. Field contains synchronizing bits processed by the NIC hardware, and it should have alternating 7 octets of alternating ones and zero sequences, and 1 octet that signals the beginning of the frame. And that is it. All right. I know if you guys later labs, I'm actually going to have you guys install Wireshark. I have it on some of my servers you can log into, but I'll let you guys work more in this. But for now, I just want to get you guys to get through a lot of the labs, the main labs, and just move on, especially since we're 2 weeks short for this semester. All right, but that's it. And also, to let you know, in all the security classes, you guys will definitely install Wireshark and use Nmap and things like that, so you'll be able to look at packet captures. All right, but that's it. Thanks for watching, and I will be doing another video shortly.